Hey guys, it's Blake from Redefined Horizons, and in this video I want to go over the first set of multiple choice surveyor exam practice problems that we put together. This is to help you get ready for a CST level exam, probably a level 2 or level 3, and or the LSIT. So it'll help you prep for both of those. And then we've got an essay format question that'll help guys prep for the LS exam, or gals. And we're going to do that in a separate video. So what I'm going to do in this video is kind of just review the answers in the study guide and for this first set of multiple choice problems. But I'm probably only going to do the first 15 or so questions, and then the questions that actually use the two exhibits, the last, I don't know, 8 or so questions or 6 or so questions we'll do on the desktop. I'm going to screencast those so we can look at the exhibits. Okay, so the way I'm going to do this is I'm going to read the question and the answers, and then I'll tell you what the right answer is, and I'll explain why it's the right answer. I'm probably not going to go into a lot of detail in these videos on what the wrong answers, why the wrong answers are the wrong answers, but I do have that information in the study guide you can download online. All right, so here's question number 1. What is typically the common source of online research in a boundary survey? And here's your options. A, NGS datasheet website. B, BLM website. C, County Surveyor Online Map Index. Or D, County Land Use GIS Online Map. So the correct answer is C, the County Surveyor Online Map Index. So in most parts of the United States, the county surveyor maintains the survey records. That's done at the county level. And so if you're doing a retracement survey, you will typically want to go and check the county surveyor's map index for available surveys. Okay, and this question number 1 is testing boundary surveying and land records research. Those are the areas being tested. Question number 2, what boundary survey information may be shown on a tax assessor map for a parcel with a meets and bounds land description? And here's your choices. A, location of property quarter monuments. B, gaps and overlaps in deed descriptions. C, parcel chain of title. Or D, bearings and distances around parcel boundaries. The correct answer is D, bearings and distances around parcel boundaries. So if you have a meets and bounds description, frequently a tax assessor will use that, the meets, the bearings and distances to COGO the parcel for the tax assessor map, and then they'll put those bearings and distances on the map. It doesn't happen all the time, but it does happen sometimes. So the areas that we're testing there, again, are boundary surveying and land records research. Question number 3, a boundary retracement survey map will typically show what 2 elements? Your choices are tax assessor parcel numbers and found property corner monuments, parcel areas and found property corner monuments, owner names and title report exceptions, or tax assessor parcel number and title report exceptions. The correct answer is B. It's going to show parcel areas and found property corner monuments, your typical boundary retracement survey, and that is testing your knowledge in boundary surveying and survey work products. Okay, then we've got a set of field surveying questions, starting with number 4. Question number 4, after a total station has been course leveled on a tripod, the next step in a typical setup procedure is... And here's your choices. A, center the instrument over the control point. B, set the backside at 0. C, fine level the instrument. Or D, run the auto compensator calibration. The answer is A. You need to center the instrument over the control point monument. So you do that before you fine level and set the backside, and typically before you run any kind of compensator. Okay, and question 4 is testing your knowledge of surveying equipment and field surveying procedures. Question 5, a GNSS baseline that forms a redundant tie in a closed loop of baselines is called, and your options are A, a redundant baseline, B, an independent baseline, C, an independent closing tie, or D, a double difference baseline. And the answer is B, it's called an independent baseline. That's because you don't need that independent baseline to calculate coordinate values on the points in the loop. It's independent. You can throw it out. We don't throw it out, we keep it because we want to check our coordinate values. And so, for example, per the Caltrans spec, you need to have a certain number of independent baselines in each loop. And basically we do that because if you don't have independent baselines, you're not going to catch a blunder or bust in your setups on your GPS observations. So that is testing Question 6 is testing error analysis and adjustment and geodetic control survey. Oh no, I'm sorry, that was 5. We're testing surveying equipment and field surveying procedures there. Okay. There's a little bit of geodetic control in that one too. Question 6. A typical source of blunders in a GNSS control survey would be, here's your options. A 1-foot bust recording an instrument height. B, multipath from building or trees. C, satellite clock error. Or D, poor satellite configuration. And the answer is going to be A 1-foot bust recording an instrument height. That is an example of a blunder. So that's not random or systematic error. That's a big mistake, and you need to find it and get it out of your data. So question 6 is testing error analysis and adjustment and geodetic control surveys, those areas. Question 7, what type of GNSS vectors are post-processed after a field survey? Your options are real-time kinematic vectors, real-time network vectors, fast static baseline vectors, or precise point positioning vectors. The correct answer is C. Fast static baseline vectors. You do not get coordinate values from fast static in the field at the time of the observation. You have to post-process that in the office. So that's question C, or answer C, sorry. Okay, and that was question 7, which is testing surveying equipment and field procedures, and also a little bit of geodetic control. Okay. All right, I'm just fixing typos as I go through here with you guys. All right, question 8. A slope stake is placed based on what combination? Here's your options. A design elevation and station plus a design elevation and a station offset from center line. B, a horizontal offset from center line and a design elevation. C, the elevations of existing topography and a design slope. Or D, the elevations of existing topography and a horizontal offset from center line. The correct answer is C. If you're slope staking, the position of your stake is based on the existing topography and the design slope. If you don't understand that, just catch the desktop video. I'm going to go through that slope staking problem that we have with the building pad, and that'll help you understand that answer. Question number 8 is testing your knowledge of construction surveying and field surveying procedures. Question number 9, dimensions of building pads at the finished floor level are typically shown on, here's your options. A, the civil engineering plans and the architectural plans. B, the architectural plans and the underground utility plans. C, the landscaping plans and the underground utility plans. Or D, the structural engineering plans and the underground utility plans. The correct answer is A, the civil engineering plans and the architectural plans. The building pad is typically where the civil engineering plans and the architectural plans interface, right? So usually the footprint of the building pad and the building pad elevations are going to be shown on both sets of plans. That is testing your knowledge of construction surveying and construction plan reading and interpretation, number 9. Question number 10. What combination of information is typically recorded in field notes for total station traverse for each instrument setup? And your options are A, instrument height, rod height, angle of deflection, and change in elevation. B, instrument height, rod height, prism constant, and angle of deflection. C, angle of deflection, change in elevation, slope distance, and vertical angle. And D, instrument height, rod height, slope distance, horizontal angle, and zenith angle. The correct answer is D. You're going to record your instrument height, rod height, slope distance, horizontal angle, and zenith angle. So if you're old school like me and you used to have to write down all your traverse information in a field book, you'll know the answer to that question. Okay, guys, that's all the multiple choice questions in that set that don't use an exhibit. So I'm going to do a desktop video for the other two. I'm sorry, for question 11 to 20 that use the 2 exhibits. I'm going to do that on the desktop so we can look at the exhibits. I'm going to screencast those. By the way, that last question, which would be number 10, that was testing... Let's see what that was testing. Sorry, guys. That was testing surveying equipment and field surveying procedures, those areas, question number 10. Okay. All right, guys, thanks for watching. Hope you enjoy the practice problems that they're helping out. And we will we'll add a couple of screencasts to the end of this video so we can go over the exhibits. All right. Hey guys, it's Landon Blake from Redefined Horizons, and this is a couple of screencasts I'm doing on the desktop to answer the last 10 questions in the problem set 100. This is the multiple choice surveyor exam prep problem set that we're releasing to help guys prep for the CST or LSIT, and I wanted to do those on the desktop so we could look at the exhibits. So let's go ahead and dive into question 11. So question 11 to 16 refer to a typical cross-section on a building pad. So this is these are all construction surveying type of questions. Okay. So I want to know that you can read a typical cross-section and that you understand a little bit about slope staking. So let's go ahead and look at this first question, 11. If the proposed pad elevation is 29.4 feet, how far back is the left side catch point of the pad from the existing ground hinge point? All right, so let's identify our elements here on a cross section. We've got the proposed building pad, which we're saying is at 29.4 feet. Okay, we got the left side catch point of the proposed pad, which is right here. And we've got the existing hinge point on the left side, which is here. What we want to know is how far back is this catch point from this existing hinge point. Okay, and here's how you figure that out. You take 29.4, the elevation of the pad that you're given, minus 28 feet, the elevation of this bench right here. Okay, that gives you 1.4 feet. This is a 3-to-1 slope. It tells you right here. So you take 3 times 1.4 and you get 4.2. That means it's 4.2 feet horizontally from the hinge point to the catch point. Okay, and then you can take your 31.2 feet left here and your 26 here to figure out that you are 5.2 feet from here to here horizontally, and we know we're 4.2 feet from here to here horizontally, so the difference is 1 foot. That's how far back this catch point is from the hinge point. Okay, question number 12. If the proposed pad elevation is 29.4 feet, what is the deepest fill that would need to be marked on a stake for the pad? Assume a stake is placed at each major grade break on the existing topography. So what we got to do is find our deepest grade break, which is going to be one of these two, and they're both at the same elevation, 24. He gives us, or we are given, the pad elevation of 29.4. So we take 29.4 minus 24 gives us the deepest fill we're going to have here is 5.4 feet, which is answer C. All right, question 13. The steepness of which slope face controls the length of the pad slope on the right side of the pad? So here's the pad slope on the right side. Here's our control line. So everything on this side of the blue line is left. Everything on the right side of the blue line is right. So we want to know what controls the length of this slope. The answer is how steep or shallow this slope is right here between GB1 and GB2. As this slope becomes steeper, this slope gets shorter. As this slope becomes shallower, this slope is going to run farther. It's going to get longer. So the answer is A, GB1 to GB2. Question 14. The use of a UAV to determine elevations of existing topography could greatly expand the potential fill volume of the building pad. Which grade break elevation is the most critical in determining the shape and volume of the building pad? So what we're saying here is that if we flew this site for our topo with a UAV, so that's going to define this black line, one of these points, grade breaks, if we change it a little bit based on the UAV elevation, we're going to really change the shape of the pad. And the answer is this GB5 right here. If we move this down or move it to the right, what happens is this slope no longer catches here, and it's going to run way out here till it catches down here. That's going to add a whole bunch of dirt to that pad. So the answer is GB5. That's kind of the critical point. And if you were really going to do something like this, where you had a proposed catch point this close to a grade break like that, and you could significantly change the shape of the pad, you would want to survey this with another method, like with a total station, to make sure that your design engineer wasn't going to do that. Or you got to pull back this proposed hinge to make sure that you catch here on this higher bench. Question 15. A swale with riprap armor would most likely be found at which location? And then I give you a set. The answer is it's going to be found right here. Okay, this is the answer is D, at the right side catch point of the building pad. And the reason why is you're going to have runoff coming down this slope, and it's going to pool here. It's going to pool up. It's going to get caught here at this catch point. That's not there's no bueno. So you're going to want some kind of drain here, or a valley gutter, or a little riprap swale to move that water off of your pad. Okay. Everywhere else on the pad, the water's basically going to run off the pad, but right here it's going to catch. Okay, question 16. The design for the building pad calls for 1 foot of crushed gravel as a base below a minimum cap of 1 feet of native earth fill. Between which 2 points will the building pad as designed be unable to fit this requirement? So what I'm checking here is your ability to look for problems with minimum fills. Okay. And the answer is going to be the shallowest point of the pad. It doesn't fit. So if this is 29.4 and this is 28, we've only got 1.4 feet, and we need a foot of crushed gravel and a foot of native earth. That's 2 feet. It's not going to fit. Okay, so there's the bust. All right. Okay, those are the 6 questions for exhibit 5 or 6 questions for exhibit 1. Let's look at exhibit 2. So this is a strip land description question, okay, and I kind of give you the setup there. We're trying to run a strip easement along this common boundary here all the way down to the North Lands of Lee here. What we're trying to, in our sale, what we're trying to do is we're trying to get access to the lands of Blake and the lands of our sale from Red Oak Road down here. Okay, so question 17 says, which of the following is the best description of the control line and width of the easement? So when I say control line there, what I mean is we're going to describe some line. Could be a center line or a side line. We're going to have some line we describe, and then we're going to give a strip of land in reference to that line. So in this case, what we really want is we want a line that runs along these common boundaries but doesn't encumber the lands of Cazares or the lands of Dixon. So what we're going to do is we're going to say a strip of land 30 feet on the left side of this line that's in purple. Okay. So the answer is D, being a strip of land lying 30 feet on the left side of the following described line. You don't want to say 15 feet on each side and use the center line, because then you're going to encumber the lands of Cazares and Dixon. We don't want to do that. All right, question number 18. What is the best description of the point of beginning for the control line of the strip description? And of the options I give you there, the one that is the best is going to be beginning at the southeast corner of parcel B. So that's going to be right here. And the reason we like that is because we want to reference one of the lands we encumber, and this is on a parcel map, and this point's easily identified. So that's why it's a good point of beginning. Okay, question 19 says, what is the best course for the leg of the strip that runs along the east line of the lands of Blake? So that's here. We want to know, how do we describe this in our strip description? Okay, and the answer is going to be then south 1 degree, 15 minutes, 15 seconds west, 200 feet along the east line of the lands of Blake to the lands of our sale. Okay, and what I'm testing here is I want to know that you're using this measured bearing, right? Because that's the basis of bearing on, that you're not using this record bearing. And I also want to make sure you understand that we need an along call. So we're going along the lands of the east line of the lands of Blake, and we're going to the north line of the lands of our sale, right? And I'm actually going to change that. It should say to the north lands of the line, north line of the lands of Lee. So we should come down here. Should actually be better to go down the east line of the lands of Kano. Nope, I like it. I like Blake. East line of the lands of Blake, but we should go to the north line of the lands of Lee, because our strip's actually on this side. Okay, so I'll fix that. So that's going to be answer B. Okay, let me just make a note of that. I'm going to go to the line of the lands of Lee, north line of Lee. Okay, question 20. What is the best description of for the courses of the access easement strip that run along the dividing line between the lands of Kano and the lands of Cazares? So that's here, and it's Red Oak Creek. That's the dividing line. So what we want is we want something that gets us along the creek to this north line of the lands of Kano, and we do that with answer B. Then along the center line of Red Oak Creek in a generally northern direction to the north line of the lands of Kano. So we want to call along the center line of the creek to the north line of the lands of Kano, and B does that. So B is the right answer. Okay, guys, that's all the questions. Again, I hope this helps. Helps you guys prep for the CST and LSIT, and I'll try and get another set of 20 of these questions out in a couple weeks. Okay. All right, thanks for watching.